Hi everyone, Tina here, and today I'd like to talk about vectors. Specifically in this video, I want to talk about the essential skills you'll need for vectors for both the foundation and higher GCSE maths courses. I have made another video for more difficult vectors questions that you'll only come across if you're doing the higher course. Okay, so let's start by thinking about what are vectors. Vectors are quantities that have both a magnitude or a size and a direction. There are different ways of writing vectors in terms of notation, so I'll show you a few ways that we need to be aware of. Okay, so let's say we have a vector which goes from here, A, to here, B. I'm going to join those points up with a line that has an arrow. That's one way of representing a vector. In terms of notation for describing it, we can say this vector is AB with an arrow going across from A to B to show the direction. We can also describe it as vector lowercase a underlined, so that's the same thing there. And more interestingly, we can also describe it as what we call a column vector, and that is 4, 2. In a column, 2 numbers. Where does that come from? Well, that's because to go from A to B, you can think about that as going 4 across to the right and 2 up. 4 across to the right and 2 up, therefore 4 and 2. You might think it's strange that we have to underline the lowercase a, but it's just to distinguish it as a vector. In the exam questions, you might see it as underlined or more commonly just bold. It's difficult to make text bold with handwriting, so we use an underline instead. Let's draw another vector now. So we're going to draw a vector starting at C here and coming down to D here. Again, I'm going to join those up with a straight line and an arrow to show the direction. And we can label this one as CD with an arrow on top, or we could call it lowercase b underlined. Or if we wanted to use the column vector notation again, that in this case would actually be -3, -5. And that's because if you look here to go from C to D, you're actually going 3 to the left this time and 5 down. So going to the right is positive, going to the left is negative, and then going up is positive, going down is negative. It basically follows the same direction as the x-axis and the y-axis, so you can think about it like that if you want. Now that we know how to represent vectors, let's see what happens when we do some operations with them. So let's start with multiplying them. What happens when you multiply a vector by a number? If we start with this vector, I'm going to call it lowercase a, and this vector here, as a column vector again, is 4, 2. Now I want to times that vector by 2. So I'm going to write that as 2a. If we start with what happens to the column vector first, all we have to do is put a 2 on the outside next to our column vector 4, 2. And then you just multiply the 2 by the 4 and the 2 by the 2. So that will give us 8, 4. Visually, what's happening is you're actually stretching your original vector a by 2. So as you can see, it's going 8 across to the right and 4 up now. So if we draw that, that will be 8 across, so there, and then 4 up. It's going to look like this. So visually, it looks like we've stretched or doubled our original vector a, and that's exactly what's happening. Notice that those two vectors are parallel to each other. So the a and the 2a parallel. That's an important idea in general. Another important idea is what happens when you have minus a. So in one way, thinking about it as multiplying a by -1. Let's have a look. So minus a, again, just working with the column vector, would be minus on the outside and then 4, 2. If you multiply that minus through, you're going to get -4, -2. Visually, that's quite interesting. Let's say you start from here, you go 4 across to the left and 2 down, you're going to end up there. Draw your vector, draw your direction, and that's -a. So do you notice that a and -a again are parallel, and they are the same size as well, same magnitude? The only difference is the direction. So positive a is going up and to the right in our case. Negative a is therefore coming down and to the left, opposite direction. Just to finish this idea off, let's say you wanted to do -1/2 a. So again, working with the column vector, -1/2 on the outside, 4, 2 here, times both the 4 and the 2 by -1/2, and you will get -2, -1. Visually, that is a short vector like this, -1/2 a. And as you can see, it is going in exactly the same direction as -a, it's just half the size. So we've seen multiplying vectors by numbers. You can also add and subtract vectors. So let's see what happens with that. This time, let's say you've got a which is column vector 6, 2, and B, which is column vector 3, minus 4, and you just want to add them together, A plus B. Great news is that you literally just add the two columns together. So you do 6, 2 plus 3 minus 4. I always think this looks way more complicated than it actually is, because all you need to do is add 6 and 3 to get 9, and then 2 plus minus 4 is just the same as 2 take away 4, so minus 2, and then you're done. Again, it is worth being aware of what this looks like visually, just so you get a better understanding of vectors in general. So I'm going to draw these out for us. Starting with vector A, 6, 2. Let's say we start here, 6 across to the right, 2 up is going to lead us there. That is vector A visually. Vector B, I'm going to stick on the end of vector A. That's 3 across, 4 down. So something like this. And the reason I've stuck it on the end of A is when you add vectors together, you're essentially adding the two vectors in a line together, one after the other. So when we then join up start to finish from the very starting point to where our B finished, that is A plus B. And hopefully you can see that visually that purple vector, A plus B, actually is 9 across and 2 down. So it matches the column vector. Let's think about subtracting now. So C equals 4 minus 5, let's say, and D equals minus 1, 3. And we want to do C minus D. So again, we're just going to write our column vectors out. So 4 minus 5, take away, minus 1, 3. And then we're going to do the two calculations separately. So starting with 4 minus minus 1, that double negative in the middle there is going to make a plus. So that's actually going to give us 5. And then minus 5 minus 3 is minus 8. Let's look at this calculation visually again. So let's say C is 4 minus 5, and I'm actually going to start C from here. So 4 across, 5 down. That's C. Now, if we were going to tag D on the end to C, just like we did with the addition example, that would look like this. So minus 1, 3 would go up here. And that is vector D. However, we're not adding this time, we're subtracting. So I'm going to draw minus D instead, which is similar to vector D, same size, same line. However, the direction is reversed. And then the combination from start to finish, so from there to there, visually represents C minus D. And as you can see, that matches our column vector 5 minus 8, because to go from there to there, you go 5 across and 8 down. Now we've seen some of the theory of vectors, let's take a look at some examples. Here's one. So A equals 4, 1 this time, and B equals 3, 2. And we're asked to write down as a column vector A plus B. So starting with that, all we do is write down 4, 1 plus 3, 2. And again, you just want to do your two separate calculations. So 4 plus 3 gives you 7, 1 plus 2 gives you 3, and you're done. Part B looks a bit more interesting. So 2a minus b this time means we want to do 2 lots of the a vector. So 2 times 4, 1. Take away the b vector. I would just break this down into pieces. So I would do the 2 times the 4, 1 first to get 8, 2. And then subtract 3, 2. That will give you 8 take away 3, 5, 2 take away 2, 0. And you're done. Okay, this next example is a little bit different. So it says A is the point 3, 2, and B is the point 4, minus 1. Write down as a column vector A, B, or A to B with the arrow on top. So if I were you, I would draw myself a little sketch just to see what is going on. So point A is 3, 2. Just roughly, maybe it would go somewhere there. And point B is 4 minus 1. So again, rough is fine, but somewhere there maybe. And then vector A, B with the arrow on top would just be going from A down to B, arrow that way. Now we can think about it. So going from A to B as a column vector, let's think, how far across are we going and how far down? So in terms of the across part, we're going from 3 to 4. So that's just across 1 to the right, positive 1. And then in terms of how far we're going down, we're going from 2 down to minus 1. So that would be down 3. Therefore, minus 3 there. Last example, this time with a diagram. So we're shown this triangle and we're told various things about it. So first thing you want to do is just read the diagram against the information that's given and make sure you're happy with what's going on. For example, it says vector OA is 5A. We can see that on the diagram. Vector OB is 3B. M is the midpoint of AB, so it's directly in the middle of A and B. And they want us to find in terms of A and B, first of all, vector AB. So let's start with vector AB. Now, to go from A to B, you might be thinking, well, surely I can just go directly from A to B. However, there is not enough information on that side of the triangle. They want us to give this vector in terms of lowercase a and lowercase b. What we need to do instead is find a path from A to B that goes via these known vectors. So what I mean by that is to go from A to B, you actually want to go round and take the longer path rather than the shortcut and come round this way. When you do that, you can say that vector AB is actually equal to minus 5A plus 3B. The reason it's minus 5A is because we're going against the direction of the arrow. Remember, with negative vectors, it's the same vector, but you're just going in the opposite direction. And that's the answer for part A. Part B, vector AM. Now, this one's interesting because A to M is actually just halfway along A to B, and you already know what vector AB is, so you can just stick a half on the outside and then your vector AB from part A. Then all that's left to do is expand and simplify if need be. Just like with algebra, expanding brackets, exactly the same idea. So a half times minus 5a would give us minus 5 over 2a, and a half times 3b would give us 3 over 2b. And that's it for part B. Lastly, they want to know vector OM. So again, good idea to try and find a path from O to M. There's more than one path there, but the one that I'm seeing straight away is to go up to A and then down to M. Let's write that down in terms of the steps that would be. So to go from O to M, we're going to go O to A and then A to M. And once you've written it down like that, you can see which vectors you know and which ones you don't. So in this case, do we know vector OA? Yep, that's 5A. And do we know vector AM? Yes, we actually found that in part B. So we can use that to help us. Just stick on your answer that you got from part B. So minus 5 over 2A plus 3 over 2b. And just like in algebra, we can simplify this now. So 5a plus minus 5 over 2a. If this was a calculator paper, you could just stick that in the calculator. If not, you could work it out on the side and you would get 5 over 2a and then just the 3 over 2b. And we're done. That's it for now. If you found this video useful, please do remember to like, comment and subscribe to my channel if you haven't already. And please do share this with anyone else that you think might find it helpful. Thanks and see you next time.